Alright, g'day everyone. So I've kind of gone a little bit ahead because we ended up losing some footage, didn't we? No, what had happened is that this mobile phone is a Samsung A35 and it has some very weird audio stuff with recording. It decided to like maybe turn on a noise gate or something and basically lost half my audio. So we've rushed ahead. Now I will explain what I've done, and you can see there's a bit of a testing setup here right now. So what has changed is I've added the ground from, you probably can't see, should probably disconnect this. All right, what we've done is we've added the ground to also power leads as well. We've added the ground, we've added the power capacitor there, little smoothing capacitor. We have our two chokes that feed the drains, and we have our output transformer. Now the good news is I'm going to disassemble this because I'm not happy with the performance. Yeah, we kind of got to the end, but I had only about 3 dB of gain, which was nothing, and then I turned up the bias and got about 10 dB. So we have had some progress, but honestly, I want it to be better. So what I'll do is I'll chuck in the Nano VNA, like so. I can turn our Nano VNA sweep. Oh dear, it was left on. Okay, well, that makes things fun to test. I will go charge the Nano VNA and then I guess we'll have to be back. However, the good news is this does not oscillate. It's all stable. You get about, I think it's 13 dB of gain at the moment. But there is things I want to change. So I don't really like this output transformer. The feed chokes, they're not ideal for like QRO levels, but they should be fine here on QRP, you know, like 40 watts or so. That should be okay. This output transformer needs changing though. Yeah, it's 2 separate windings, and I've realized I've got 1 turn and I've got 3 turns because yeah, I went down the ratio a little bit there for efficiency reasons, I believe. Originally it was 5 turns and I got like 2 dB of gain or something. This made it about 10 dB or something, so I had the ratio wrong. And then I realized this is 3 turns, which is a 9-to-1. Now the best way to make 9-to-1s is with coax, so I'm going to get rid of this and I'm going to go for the coax transformer, which is much more efficient. So yeah, I believe in theory we'll be able to hit 75 volts peak if everything's absolutely perfect and lossless, which it's not. But I think we're looking at around 40 watts, about that type of voltage level. I'm going to have to double check when we get our oscilloscope on it and stuff like that. Alrighty, I'll go charge the Nano VNA and I guess I'll be back with you. And we're back, hopefully with a VNA that actually wants to turn on. And yes, it does. All right. Now we're going to hook up our input and output here because what I want to do first is sweep the amplifier. So if I plug that in, the return loss as well, turn the return loss trace on, we should see a constant negative 50 dB of gain, which is what we do see. Yep, I think, oh, there's a little bit loose there. There you go, pretty much all exactly 50 dB of gain there. All right, I'm going to turn on the power supply. If I were to plug it in, that would probably also help. Very good. Turn that on. Yep, I think we're ready. So what I'm going to do is we're going to sweep the amplifier. This is from 1 megahertz to 15. I might actually go to the other trace where I've got another profile that sweeps from basically 0 to 30. Yeah, 10 kilohertz to 30. We're going to go that one. Turn our trace on, and you can see it's a nice constant flat 50 dB. So this is our reference level, right? So anything higher than this means we've got gain. Anything lower than this means we are losing power, basically. So what I can do is, well, this should be on 13.8 volts, which it is now, pretty much. I can turn our amplifier on. Yep, and nothing happens because that's what this amplifier does, just no current, nothing, because it uses 0 power until you engage the PTT. So we'll do that, we'll flick the switch, and you can see we have a graph here of gain at, what are we, 7 megahertz. We're at 37 dB of gain. So basically, oh, this is also climbing up in the bias there because I turned the bias right up. We have about 13 dB of gain, which is pretty low. And as you can see, we're at 10 dB at, where's that, 18 megahertz. We're at 50 dB, which means we've got zero gain at 25 megahertz. And at 30, we're at 56, which means we're actually losing 6 dB of power. So if I turn that off, there you go. You see, that's where 0 dB is. So, yeah, this amplifier does have a bit of capacitance to the gates. You can't really use these MOSFETs up on, 10 meters. But down on 7 megahertz where I like to operate, you saw it, nice 13 dB of gain there. What we are going to do, however, is swap out this output transformer. I think these chokes are okay, but this output transformer definitely needs to change because I think I can do more efficient than this. Alrighty, I'm gonna unsolder stuff, so I'll explain the bit that I did add, and as I remove them basically. Turn our power supply off, that would probably be a good idea. So we're gonna disconnect our amplifier. Like so. Now we can start working on this assembly. I can put this in an OBNA over here, I suppose. Actually, I probably should put it back on charge because it's only been charging for like 10 minutes. But, well, as long as it gives me that sweep, I guess I'm good. Alrighty, first step, we probably want to discharge the caps. So, I think the way to do that is actually just turn this on. Alright, should be all discharged. Second step, let's start removing stuff, eh? Alright, how much of this can you actually see in frame? Because that is a relevant question to ask. I've been caught by that before. Yeah, that'll probably do, I suppose. Alright, let's start removing stuff. So, our output transformer connection went here on the little relay here. And a ground lead, like so. Our output transformer connects to this pin here. So I'm taking off the output transformer first. And this pin over here. That should be almost free. Except for it's not, because the drains are also feeding here, so they're chokes. What would be the best way to remove you? I suppose I could just heat this whole thing up and yank the wires off. Come on, off you come. There we go, that's one. Alright, heat them up and I'm free. Alright. Oh, you do need a, I'm pretty sure you do need this capacitor across the transformer as well to make this thing work. This is a transformer design, so it's a single turn. This is our, obviously, single turn here, and that's 3 windings, which is actually low for our ratio that we would normally want, but I'm only trying to hit 40 watts, so I think 3 turns is enough, just. So what we're going to do instead is, if I can find my little bits of cut up coax, which I've been misplacing all over the place, I suppose, I can wind a different style of transformer that uses a coax, and they are auto transformers, which means they do not do DC blocking, but the efficiency is, I don't know, dB higher at least, I think. They're a lot more efficient at least. So I can go find a bit of coax. Do I have some, or have I all packed it away? I got this roll. I don't think I've actually got any. I think I've used it. Oh no, here it is. That's probably not enough. So we're going to see how many turns we get on this with this. I'm pretty sure we're only going to get like 2 turns, maybe. Yeah, 2 turns with like reasonable tail lengths there. So I think these transformers can fit maybe 4 turns. So we're going to do at least double this length, basically. And that will be our transformer. I do need two of them though, they work together. Alright, so let's... Well, hang on, what am I doing? Just realized. What I could do, just wind it as I go. So I'm going to take a guesstimate first about how much we need. So somewhere around that, so that's where I'll put the transformer. And if I do need less, I can just unwind it. Yep, like that. Alright. Let's try 2, 3. Oh my god. Well, that was a bad guess. That was a bad guess and a half, actually. I'm going to feed some of this back. So let's do that. Let's feed all this stuff back. Okay. Like so. If I could actually get that coax in there. It does actually fit 4. I know it fits 4. Alright. Obviously we're going to have to tighten that up. But the length of that's pretty good. So what I can do is, I'm going to obviously tighten this down, so I'm going to have longer tails anyway. Take this out again, cut another length that's this long, and wind up those two transformers. Helps if I went like that. Alright. Yeah, winding transformers is not very hard, especially when you're making coax transformers, that's for sure. Alright, there's our second length. Let's wind these up. Now, I'm going to wind one at a time, sorry. I'm not that special. Can't wind multiple transformers at once. Alright, let's go 1, 2, 3. Oh, done it again. I haven't left myself enough, actually. So we're gonna, come on, do that. Just give us a little bit extra on the tail there. Yeah, it's plenty. All right, that'll do. Let's tighten that up. And 4. There we go. So we can tighten her up. There we go. That's one transformer. And these are going to work in pairs. Obviously I cut this coax the same length, so I can just do that. I say this transformer is almost aesthetically pleasing, isn't it? Doesn't look too bad. Now the way that these guys work, because we're going for a, well, there's two ways you could actually do this. If this was a 4-to-1, you could have shield, shield, coax, shield, shield goes one side and center, center goes the other side. And then you'd hook these up. Shield is one connection out. Then the other two, center, shield is a center tap. And then you go shield on the other side is the other output. That's a 4-to-1. But for a 9-to-1, you basically make 2 center tap transformers. And yeah, kind of like do shield, center, and shield again, I guess. I'll show you. It's a basically a 9-to-1 transformer, but well, it's actually 2 4-to-1s put together to make a 9-to-1, I should say. Alrighty, let's do some stripping. I don't think these pliers are going to work at all. You never know, though. Oh wow, they actually worked. Okay. It's a bit aggressive. It's a bit, yeah, it's a bit much. Oh well, should work. Actually going to cut them the same as well. These are actually a little bit long. Need to think about how I want to connect these, because I also need an extra transformer. I need to 1-to-1 to make a balanced output. Well, basically I need to go from balanced to unbalanced, and I need an actual 1-to-1 as well. I need a third one of these. But I will get there. Okay, and DC blocking capacitors as well. All right, let's get rid of that. 'Cause why not? I'm gonna do this. Jesus. I actually didn't think that would work. Alrighty, so to make a 4-to-1, we all know how to do this. You take one side. Yeah, you start from one winding. The winding goes through the transformer. So you'd have another winding. This is the same winding on the other end, obviously the shield. Then, I can hook this up at the right length, that'll be nice. You do this, center the shield. Well, actually, if we say we're starting at the shield goes through. So this is the center tap, so the shield and the center would go together. Like, oh, can't even see it. I'll just do it this way because this is the way the transformer wants to work out. Shield and center goes together, and there are 3 connections for a 4-to-1. So you build 2 of these, and then the other guys, this center tap goes over here, and this here goes over there. So you end up with 2 4-to-1s where one of the windings overlaps, which means you've actually got a 9-to-1. I'll display that on screen or something. But this is the most efficient transformer I know how to make. They're pretty good. The frequency may not be the best because I've got a lot of tail here, but I probably need it. But there you go. All right, I'm going to make the other one, wind the other one up. Maybe I'll fast mode it. Alrighty. Now we have to make the connections. So first things first, this is one transformer. I'm just going to do it wherever it wants to sit. So basically, that is 1 4-to-1, like that. We'll make another 4-to-1, and we'll just do wherever it wants to sit. It has to be shield, center. We'll put that together as well. All right. Now we have 2 4-to-1s. So what we have to do now is overlap the windings. So basically, yeah, this would work. If you basically, this is let's say 2 4-to-1s in parallel. You would never use it like this, although it would work as a 4-to-1 just fine. To make a 9-to-1, so imagine we've got 0 volts, 1 volt, 2 volts. We'll just say this is, starting at 0 volts, AC or whatever. This here would be a 1 volt tap, and this would be 2 volts. What we can do is this. If we overlap them just by 1, transpose it over just by 1 there. Like so, what you have is actually 4 taps on a auto transformer now. So we'll say 0 volts, 1 volt, 2 volt, 3 volts. Well, what we're actually going to do, we're going to feed in here, this center section, and then that's 1 volt across there, let's say. And then because there's an extra 2 windings, an extra 2 spots there, we're going to have 3 volts out. So we're tripling the voltage, which means we're doing a 9 times impedance ratio there. But I actually have to physically solder this together, and I haven't quite worked that bit out yet. Alright, I'm getting very, very tempted to wrap copper around this and just make the connections that way to everything, because there's no way I'm going to chuck that on there. Now, here is our outputs on the outsides. They're our high voltage. Here's the inputs on the inside there. But first I'm going to go sweep this. So I'm going to pause the video, and I shall put a resistor across here at 450, well, I don't have 450 ohms, we're going to go 470 ohms if I can find one. And then I'm going to chuck the nano VNA on there. Actually, we're going in the reverse direction, aren't we? 9-to-1, so I could put a 10 ohm resistor across the inputs and chuck 50 ohms across here. That would actually be more what we want to test. Actually, we will go down to low impedance here because we want to check 50 ohms here actually. Don't really care about the high impedance stuff. Alright, I'm going to pause the video here, and I'm going to come back with once I found the resistor that I need. Alright, I saved you the effort of having to watch me fail to solder on some resistor to what I'm doing here. But anyway, you can see the setup. So this is our low impedance side, the two center taps, and then the outside taps are going to be our high impedance side. So we've got 5.1 ohms, and 5.1 times 9 is not exactly 50, but I'm also not exactly that good at math, so it's going to be close enough. We're only hoping for close enough, right? All right, let's go check what the NanoVNA tells us. With any luck, we should be, oh, what's that? Less than a 1.1 SWR? I don't know, my math is failing me at the moment. So let's give it a go. All right, we shall plug her in. Come on. Wow, this SMA cable is being a little bit funny here. All right, what have we got? 49.5 ohms plus 470 nanohenry. Okay, whatever. Honestly, this does look fairly bad. Hold on a second. I am expecting a result that is much better than this from this style of transformer. That's a little disappointing. Okay. Alright, I guess all I can do, unsolder the resistor. And, I mean, I'm sure it'll work. It's just, this is not a great transformer. Usually these things, when they're built like this, go up to like 50 megahertz or so. I do have long leads, to be fair. And this is a big resistor. Alright, okay. Let's unsolder it, I suppose. So how am I actually going to attach this? I haven't quite worked that bit out yet. So we've got our two chokes that we need to connect. Push you across up here a little bit, I think. Okay. Got our two chokes that we need to connect. I think this probably would call for a little bit of helping wire, I suppose. I need very short bits of maybe this. That's super thick insulation, but I guess it'll work. Just so I can solder this down onto the everything. There we go. That's our completed output transformer, I think. We've got our output connections here and our input connection there. Oh, we forgot the drains. Ooh, do I put them on? Where do I put these? I think I will put them on the end of here. So, all right. Just need to make our connections to the drain, which is this center terminal, and also the tab. But soldering to the tab is going to be impossible, so we'll just go center, eh? Oh, this pin's getting very weak, isn't it? I think I might have an issue here. I bet you this MOSFET's going to break. Oh, maybe not yet, but she's mechanically fragile. Alright, now we have an output transformer, but what we don't have is DC blocking. So, wow, that's like kind of hanging over there, eh? DC blocking, I always use those big X-class capacitors, which probably should be Y-class, but anyway, I will go grab them out of the box if I don't have any spares here, which I don't. So I just need to couple on this RF. Oh, actually, we need to build a one-to-one, and we're back. Rightio. Okay, so my plan now is I have to somehow attach this to here. Go through DC blocking capacitors actually, so I'm going to need a little bit more coax here just to make the jump. I need just a little bit of short stuff I've got probably lying around. I guess this is either of these appropriate. That being said, oh, will this be long enough? No, it's not. All right, we're gonna go for this. And oh, there we go. So that's going to be over there, so I need to be about there. Yep. Another little bit. There we go. Okay, I can start to smell the glue gun, so probably not too far away from doing that trick. Gonna do this. Nip it there and then try and push that center through. Oops, if you can see. Come on, center, come. You don't want to be in, you want to be out. Yeah, like that. Come on. There we go. I can't unfold all that braid. Mind you, I don't really need to. I only need a little bit of shield. So I'm probably going to use the insulator, obviously, to go this side. Like so. And get rid of most of the shield. Alright. Start doing some stuff. Alrighty. Tell you what, this feels bad, doesn't it? Oop, using hot glue like this. Alright, I'm going to chuck them there, I suppose. Or I could do future expandability if I move them out just a little bit. Oh, that glue melted. Come apart. Okay. It doesn't matter, I'm going to glue them to the board anyway. Alright, I'm going to just give myself a little bit more room. I'll put them there. Alright. Let's put this 1-to-1 in. So, alright. All I did is same thing, 4 turns. And also have this here. Alright. Gonna do this one to here. That is far too long. Yeah, that's far too long. I can't use this. So I think you can do another trick where you kind of just like expand out the braid a little. Leave a little hole for the center to go through without actually cutting it. Just fish that center out of there. Oh, I don't think it's going to work though. I can see it's trying to, but I don't think it's quite going to work. Or maybe. Are you going to let me pull you out of there? Are you stuck in there for good? Oh, we've got it. I think. Oh, there must be like a single strand or something holding that. Let's have a look. Oh, we should have that. There we go, got it. There you go, braid and shield separated there. Alrighty. That being said, again, I don't need that much braid. Shield. It's immediately gonna chop it off anyway. Alright, let's clean. Yep. Get our solder. And start installing some stuff here. All right. Yeah. Go right up to that center. Oh, already is basically. Okay. Yep. I do want it to be not straight, I want it to be curved, but I can just do that by touching it, the soldering iron, like that. Let's give myself some wire there. We'll do the hard part first. We'll go this side. Solder it down to the board. Like so. Come on. Well, that's definitely too long, but it's gonna have to do, I suppose. Oh no, that's not even gonna work. That's way too long. Let's get rid of that. Let's add a little that. That's our output connection to the relay. So the transmit side. Shall just fold those down a little bit. My soldering iron is dirty again. Now we're using DC blocking capacitors because these are auto transformers now. Just going to solder it wherever it wants to sit. So that side wants to be ground, that side wants to be shield. Normally you have the option of paying attention to phase so that your output phase is opposite to your input phase, so you don't try and, you know, have the input relay acting like a positive feedback loop. But I don't think I care, and I don't think it'll oscillate anyway. Those relays usually have about, what, 50 dB or something down, and I've only got 13 dB of gain. So, you know, what's the point? Now I need to connect onto those. Now, where is our little jumper piece of coax? Somewhere here. There it is. Yep. So we'll solder all this up. Like so. Alrighty. Solder. This should probably be equal length, but hey, it's 40 meters. I don't think I care. It seems to be a bit of a running theme with me, I think. There's a lot of things that are good on 40. I'm not one of them. All right. Now, let us try this. What are the chances that this is going to work? More than 0? Is this going to be a better transformer? Are we going to see more than 13 dB of gain? So now I can explain the whole network. You have 2 chokes that feed your MOSFET drain pin. The MOSFET either takes it or it gives it away. If it takes it, it just goes shorted to earth. If it doesn't take it, it's got to go through this transformer. So one of these will be shorted to earth, one of them will be a higher voltage. This thing will triple the voltage of whatever is on the MOSFETs. This has 12 volts on it. You can send that out if you really want to, but that's not good. So you should block it. So DC block capacitors. You have to go through a 1-to-1 transformer because we're shorting out a side. If you don't, you've got a balanced output shorted straight to ground, and you're shorting out one of the MOSFETs. So you do need this as well. Then that's it. So let's try a complete amplifier. I think we're good. I don't know if we're going to oscillate or anything like that. I don't think we will. It seemed pretty stable. So let's fire it up. We want our nano VNA. We want our 50 dB attenuator, because, you know, we don't want to amplify a whole heap of power straight up into the nano VNA. It will not like it. And we need one more SMA cable for the input. Rightio. So what are we going to see? What are we going to see? And I assume the answer is nothing, because we're probably not even in frame. Okay, I'm going to double check. Yeah, we're in frame. All right, let's turn this on. Should see a perfect SWR because it's in receive mode. I'm going to try turning the... Oh no, it should be fine. Okay, let's turn this on. Well, it didn't short out, so must have all these connections okay. They're not shorted. Whoa, that drain pin is super close though. Hang on. That drain pin there is like, must have been less than a millimeter away. Wow, that was close. All right, let's try that again. 13.8 volts. Put the 50 dB gain. All right, well, 50 dB loss, I should say. So we're at, you know, that's our reference level. That's 0 dB. Actually, I am going to go all the way up to the last profile there. The one that shows from 10 kilohertz all the way up to 30 megahertz. We'll chuck her in gear and see what we see. That seems pretty similar. I'm not going to lie. That is almost the same. 13 dB of gain. Also, these transistors are very biased. They're biased pretty hard. I'll turn off the input. 800 milliamps of bias. So, yeah, all right. 13 dB of gain. If you do want more, you do have the option of going not necessarily a 4-to-1 here, where I've gone down to 10 ohms on the input. You do have the option of maybe going to like 20 ohms or something, maybe, you know, 6 turns in, 4 turns out. That's a guess of the ratio. If you do that, you'll have more voltage swing here, so you'll have more gain. Not really sure what else you can do. 13 dB does sound a little bit low to me for MOSFETs. I would expect somewhere around 17 dB. But this is a baby amp, and it's probably good enough, honestly. I don't really have a good way of testing this with higher power levels. I do have a RF and a QRP amplifier. I'll show you guys that. Welcome to my QRP amplifier. This one actually has a whole heap more gain than that, because it also has these first stages. But yeah, that's probably 8 turns in, 4 turns out. This is a center tap drive. This is a very bad design though. The trace length is super long, so I've had to add a whole heap of bypassing on it. And even like more termination across the gates there, because this thing oscillates like crazy. And I didn't understand that I needed a blocking bellin, well, sorry, 1-to-1 bellin there, so this whole setup doesn't work. I need to redesign this board. But I can use this to drive that and see how much power I get out of it, but I'll do that another day. So maybe one more video for testing the actual output power of this. I'm not going to say happy with it. The other thing I could also do is build a filter up here, which is why I actually put this over here and not right over near it. Could build a 40 meter filter as well, but I already do have one. This is my low power 40 meter filter, so nothing special, Chinese capacitors, so probably not the best results, but it measures okay on the VNA. All right, I'm going to leave it at that and say 7.3, and we'll try we'll try to make this actually put out some juice properly in the next video, I suppose. This is probably going from negative 10 dBm, oh, this port, sorry, to about 3 dBm, maybe 2 milliwatts drive at the moment. Oh, sorry, 2 milliwatts out, because it only gets 100 microwatts from the Nano VNA. I'll drive it harder when I get the HackerF and QRP preamp set up in line. So that'll be tomorrow's job. All right, 7-3 all, VK4 Delta Lima.